All right, does everybody have a handout sheet? Yes.
Oh, you told me to do something for rodeo.
Oh, you did?
Yes.
Okay, I'm ready.
It's $495,781 for 1 kilogram. It's
Wait, say that again, how much? 4,000?
495,000.
For a kilogram?
Yeah. And then it can be used in batteries, in jewelry, specifically my mom's ring. She's allergic to white gold, so Dad had it coated in rhodium for her.
What?
And then
I never heard that.
it can be also used in capacitors.
Capacitors?
Oh, capacitors.
Wow, that's a thing. Hey, if you get that in writing, I'll give you extra credit. Can you get that? You have it in writing somewhere? I have never heard that rhodium was expensive like that.
Yeah.
Wow. I did not know that. All right, good job. Good job. Anyway, put that in writing and give that to me, and I'll give me where you found the reference, okay? All right, so what we're doing is you guys got done with the lab. For me, it's kind of like a pre-lab because the lab I really want you to get into is the candle lab. Now, I'll mention this again. You do need a standard candle. You probably won't start the candle lab until, see on Tuesday. Thursday would be the earliest, Friday's most likely, okay? And then once you start it, you'll probably be in the lab for 4 days. So you'll have 4 different times, and I know you're gonna think, I can't look at a candle for 4 class periods. You'll want 5. When you get done, you'll say, I'm gonna do more. So trust me on that. And what I'll do is I will set you up a little bit about why. Why are we studying the candle? Why is that so important? And you'll see me all year referring to the candle lab when I say, remember this, remember that? And I'll refer to it as I get to different chapters in chemistry. All right. Anyway, what we're going to do here, let's talk about the lab you just got done doing, all right? I loved what you were doing, but you probably want maybe a few more answers. So I can't give you all the answers, but we're going to go over a few of these. One thing in chemistry that you're going to find, we're going to do this later, we have some other ones, but they're called indicator chemicals. Now, indicators are chemicals that, there are different kinds of indicators. Now, the ones I'm using are called acid-base indicators. Now, what happens is, when you put them in acid or base or neutral, they can change colors. Now, there's some indicators that can only change 2 colors. Some can do 3, all right? Some maybe 4 on the edge. But they can change colors and let you know what's going on. Because right here, what do you think's in this beaker? It looks like water. It's not. It's not water. So how can I tell? I could actually, even if I stir it, nothing's going to happen. But I could put an indicator in there and try to figure out what it is. Everybody with me? So an indicator can come in different forms. It can come in the form of a liquid. See that? It could come in the form of a powder, or I can buy a company who puts a chemical and coats it on a piece of paper, and I can use it. They're called test strips. Maybe you know somebody who may be diabetic. They might test their blood or something like that. Those are test strips. Or maybe you have a pool and you dip a little thing in there and put it next to a color code, and you say, hey, the pH of the pool is such and such. And those are test strips, okay? So these are called indicator chemicals, and when they first learned about them, they said, that's pretty neat. And it is pretty neat. There are lots of pH acid-base indicators, but the ones you learned about today, we're going to go and look at some of those. Let's take a look at BTB. BTB, the real name is bromothymol blue. Okay, and that's why you don't want to call it that. You say BTB. So what we want to know is what? Yes, I'm sorry.
Does bromothymol mean like bromine?
Bromine would be in it, and then I don't know if you know what thymol is, but in organic chemistry, you know what benzene is? You ever heard of benzene ring? Okay. Benzene ring is usually the start of many, many chemicals, and thymol is one of those. I'd have to look up the exact what it looks like, but so it probably has, I could look it up, what it actually looks like, but it's called bromothymol blue. Excellent question. And now you know it's not that scary. If I can figure out what thymol is, then it probably has a bromine on it, like that. All right, so what I want to do is let's take a look and what happens. What happens to BTB in different environments? So let's take a look. Let's do this one. This right here, I'm going to start with some hydrochloric acid, okay? So this is HCl, hydrochloric acid. There we go. And let me put my goggles on. So we're going to start with HCl. So this is an acid environment. So what happens to BTB? Now right now it's kind of blue, isn't it? Okay? And what happens to BTB in an acid environment? Okay, so what do you think? It's kind of like, it looks orange, it's kind of like yellow, isn't it? And I think you saw yellow when you did the popcorn lab, didn't you? So every time you saw BTB change to a yellowish color, then it probably indicated the presence of a what? Acid. Very good. Let's try another one. Yes, go ahead.
Isn't hydrochloric acid some very strong acid?
Okay, and even though I'm not going to get into that real deep, I'll dig into it a little bit, okay? You actually make hydrochloric acid in your stomach. The word strong is difficult in chemistry because I could have a thing very concentrated acid and that would hurt me. But even a little bit of hydrochloric acid, even if it's watered down, is still called a strong acid because 100% of it splits up into ions. So if you were to study acids and bases, the word strong wouldn't come up because you can say concentrated, and you can buy hydrochloric acid very concentrated, yes. As a matter of fact, in a hardware store, they don't want to tell people we're selling hydrochloric acid. And a lot of kids who take chemistry might go, hydrochloric acid, I think I'll buy some of that. But they do sell it, where they sell mortar and stuff. It's called muriatic acid. So in a hardware store, they say muriatic acid, but it really is very concentrated hydrochloric acid. It's very dangerous. So, but I'm glad they don't call it hydrochloric acid in there because a lot of kids who take chemistry, they go get it. Well, I guess you could go get it. All right, let's try another one now. Let's do, this one is a base. Now, you don't know exactly what a base is, but it's kind of the opposite of an acid. How about that? For right now, let's talk about that. So, this one is called a NaOH, and again, you're going to learn how to write all the formulas and stuff like that. This is sodium hydroxide. Sodium hydroxide. And I'm going to put some BTB in there. Yes?
Sodium hydroxide is also called caustic soda, right?
Yes, and you can find it in a hardware store again, and they call it lye, L-Y-E, and that also can hurt you. So here we go. What do you think? Okay. As a matter of fact, when I bought this, when I originally bought BTB and it came to the school, it was actually another color. It was neutral. When they sell it to me when it's not an acid or a base. And so here, when it's an acid, it's kind of yellow. When it's a base, it's blue. But when they sold it to me, it was actually green. So this is one of those indicators that has 3 different colors. Now one thing that, let me see if I can get a thing here. Here we go. One thing that people don't understand about indicators is what I'm going to do is I'm going to put some of this in here, okay? See what's happening? The blue color didn't disappear, it's still there, isn't it? But what I do is I'm playing this little game. And if it's more acid, then the indicator is yellow. If it's more base, it's blue. I see that? So all I'm doing is playing this little game with the indicator. It can go back and forth and back and forth. Now if I want to take, and I don't know if I have enough time, but if I want to be real careful, do drop by drop by drop, I can get it into the green. You get that? It has to be right exact in the middle though. So, is everybody okay on BTB? So every time you saw it stay blue, it probably was in what they call a base or alkaline. You ever heard the word alkaline?
Yes.
Alkaline means base, yes.
Yesterday when we were blowing into the...
Oh, we're going to do that again.
Okay.
You're the only person in all 3 classes that are allowed to do that because I knew I was going to do it today anyway, so I'll let somebody else do it. So
Okay.
don't give it away. So. All right, let's do the next one. What about litmus? What does litmus do? So what we're going to do is we know that, where am I? Okay, here it is. Here is HCl. This is hydrochloric acid. So let's take a look. And let's put some hydrochloric acid right there. And again, it doesn't look like acid, does it? And so what we're going to do is say, well, let's test it. All right, so the first thing I'm going to do, this is called red litmus paper. And again, you can buy red litmus paper as this form, as a test strip, as a powder. I can even make it in a liquid. Some magicians will use this, and they'll have things change colors in a powder. They can put it on there. So let's take a look. What happens to red litmus paper in an acid? Uh-oh. Get over there. Oh. All right, so what happens to red litmus paper in an acid? Stays red. Stays red. All right, let's do another one. How about blue litmus paper in an acid? Watch now. Ah, okay. And then this is called pH paper. And I'll tell you about this one too. I'm gonna put that in there and see what happens. Uh-oh, stay right there. Don't go anywhere. Whoa. Now that probably didn't happen in your lab. I don't think anybody had their pH change red, did it? Okay, so what happens is, just like if you do a pool and you check it, same thing can happen with pH paper. Let's take a look at this right here. This pH paper has not one indicator, but 5 different chemicals in it that can change different colors. So I can get a lot of colors out of that paper. And what you do is you match it up. Let's see if we can match that up. What do you think about that? That's like 1 or 2, like that, 1 or 2. And by the way, in the acid-base world, anything below 7 is an acid. And if you get further away from 7, it's a fairly concentrated acid. So we have a pretty good acid here, don't we? So that's why that turned red. Now, what about litmus? What's my litmus thing? In an acid, where is it? I'm sorry. Here it is, red litmus paper here. In an acid, I got my, here. Okay. I'm gonna do another one now. Let's do the base. Let me do the base over here and another one, another petri dish.
Bless you.
So is everybody okay on the acid results?
Bless you.
Let's do the base now. Base. Okay. No problem. And again, what's it look like? I mean, there's no way I could tell that that was not water, but we can use indicators to help us. So let's do the blue litmus paper there. Get on there. All right, what happens there? Okay, and what about the red? No, that was fast. You probably missed it. Did you miss that? Let's do the red again. Oh, look at that. And let's do the pH paper. Oh.
That is it.
So now, let's take a look. Let's look over here now. The low numbers on the pH paper are below 7, and it's not one of those, so we turn it over. Ooh. Now, when you get close to 14, that's about as high as you're going to get with pH, and this guy's about at least 12, isn't it? So he's up there pretty high in the pH, and anything away from 7 has a possibility of hurting you. Dishwashing detergent, if I put a little water in there and put one of these strips on there, it turns navy blue just like that. It's very alkaline. Most soaps are bases, but some soaps are mild. So they might give you somewhere around 8 or 9, but some of them, NaOH for example, is very strong. And all right, so let's see if we can give it a little memory trick, okay? What do you have here? What happens to blue litmus paper in an acid? Blue, okay, and then what happens to blue litmus paper in a base? Stays blue, and then what about neutral? It would actually stay the same color also, so it would be blue here. So blue, red here, and blue, and blue. And what about red litmus paper? In neutral, it's red, of course. What about an acid? Red, and what about base? Okay, so we need a memory trick, and I'm gonna talk like I'm real down Southern Texan, okay? It says, blue turns to red, acid. Okay, so anyway, I don't know if that's Texan. I just made that. It's just a weird voice. How about that? Blue turns to red, acid. Does that kind of rhyme a little bit? Okay, blue to red, acid. Okay. Anyway, so once I know that blue to red means acid, then what's the opposite of that?
Red to blue.
Now I have it memorized. See? Blue to red, acid. Okay. Anyway, if you memorize that, now you got them both down. And you don't have to memorize the pH scale because you usually have that. There's a lot of different colors there.
Wait, but red litmus didn't turn to blue and acid, right?
Say it again.
The red litmus stayed red and the acid.
It did. So, but blue to red, if blue turns to red, acid. But what's the opposite of that? If red turns to blue, then it has to be a base, doesn't it? A base. So anyway, let's do that. So anyway, the pH scale goes from 0 to 14. It goes from 0 to 14. We don't need to get into the math on that, but it has to do with logarithms, and we won't get into the math. How about that? And anyway, numbers that are 7 are called pH neutral, not an acid or a base. And this little thing would indicate that. Did you ever get any? Did you ever get that thing to change kind of a lime green or kind of like a yellowish green? Then it was probably pretty close to neutral. But if the pH paper changed anywhere in the reddish, orangish, it probably was acidic. And if it was in the dark green and navy blue, and I don't think you got, I didn't give you anything to get navy blue, but that would be more alkaline base, like that. All right, so yeah, so red, orange, and then this is like darker here. Well, let me ask you about some questions now. What do you think would happen? What do you think would happen if I put, let's do, what do you think would happen if I put vinegar in BTB? All right, what do you think? So I don't, how am I supposed to know that? Well, let's think about that. What do you know about vinegar?
It's kind of acidic.
Yeah.
Okay, as a matter of fact, on the bottle, it says it contains 5% acetic acid. What's 95%? Water. You pay a lot for water, you know that? Anyway, but it does have 5% acetic acid. So if that's the case, what do you think will happen with this?
Yellow.
All right, see, now we can predict that. So BTB, when it starts changing into the yellow zone, then it's showing acidic, isn't it? And when it stays blue, it's in the base. And BTB happens to be the one that has 3 colors, though. It can actually be green and it's neutral like that. All right, what about litmus, though? Litmus only has 2 colors, right? Either your pink or your blue. And that's it, red or blue, right? And it has no middle. There's no middle there, like that. All right, oh, I forgot the baking soda. Dang it, I'll go get some. And then we'll do that. And then how about Alka-Seltzer in BTB? Let's do that. Ooh, I'm right now out of beakers.
Do you want me
Okay, wait a minute. Oh, good, I got it, okay. And you already know this one, don't you?
Yes.
Okay, so put that there.
But you can see the green before it goes to yellow.
Oh, that's, and I still see a little bit green, don't I? So what's interesting is that there is something in here that's acidic. There's something in here that's acidic. But like you said, the green, there are other parts that maybe aren't as acidic. There you go, like that. All right. Anyway, it kind of opens up a door to seeing things.
Why is it called Alka-Seltzer? But
Well, okay, the actual company that's had this out for over about 100 years, Alka-Seltzer, I'd have to look up why did they decide to do that. Now, seltzer I get because the bubbles, see the bubbles? Here's what people used to do, and they still do it today. They get a glass of water, and they put this in there and let it completely dissolve. And they drink it, and it's really bubbly. It's like bubbly, and it goes down in their stomach. And the reason they do it, if they have upset stomach, and they just don't feel good, people use this for a long, long time. Now we have some very more modern medicines, you know, very specific. You know, if you have a headache, you take this. This actually on here, if you read the package, it actually contains aspirin. So it has a chemical that will soothe your stomach a little bit, settle your stomach a little bit, and also if you have some pains, it'll take away some pain. So people did this for a long, long time. Your grandparents probably would know about commercials about Alka-Seltzer. And yes,
Now we use bismuth and like.
Yeah, what now?
Pepto-Bismol. We use bismuth now, like Pepto-Bismol.
okay, now Pepto-Bismol is in a liquid form right now, and it actually goes down and coats your stomach, and you don't have to worry about adding aspirin. Some people, when you take aspirin too much, it bothers your stomach a little bit. So, hey, great question. Okay, now, let's go down here, and what happens when you put NaOH in BTB? NaOH is sodium hydroxide, and this is a base. This is a base. What happened to that one? It was blue. And what about an hydrochloric acid in BTB? Orange. That was kind of yellow. I'll say yellow orange. Right. And I have to do this one and this one, okay? And I forgot the baking soda, so I'll have to go get it. Now, let me, it won't take very long.
That class. I thought that was really neat.
It's David. Yes.
Oh, see, I was trying to remember what his name was, and I was like, I couldn't do it, but it's David.
Yes, but I have some of the best ink capacity and I can snipe. Yeah, but I can follow you with my and the shot hits
Okay. Let's do something. Everybody has baking soda at their house, right?
Yeah.
So I put a little water in here because we do need a liquid. We do need it to be a liquid. Whoa, a lot more than I need. All right, that's all right. All right, so what do you think? BTB and baking soda.
I hope that makes it fun.
I just thought about something. There's so much powder in there right now. Even if there was a color, you wouldn't be able to see it. Can you see through that?
Yeah.
Yeah,
Okay,
it's
all right. All right, ready? What do you think? What's your guess?
I think it's gonna turn blue.
Yellow,
I think it's
blue,
blue.
I think
green.
it's gonna be blue.
Purple.
All right, so actually baking soda is alkaline a little bit, so it actually is it's a base. All right, good job.
But
All right,
you can still see like the rim of around.
yeah, it's interesting.
It doesn't go all the way in.
Somehow maybe it hasn't gotten there, or that's interesting about. That's good. I'm not sure about that. Let me shake it a little bit.
Slowly spreading.
Ooh.
It still
But then it's like
stays.
in the middle, you can see that it's.
So the middle might be the actual powder. Some of it hadn't dissolved yet.
Like once it settles,
Ooh.
it keeps the rim around.
That's kind of neat. I've never done that. Okay, that's good. Let's go over here and we'll go ahead and I'm gonna stop the video. Sorry.